Alright everybody, welcome to Module 11, the last module of the third unit of the course, and here is where we are going to spend a little time talking about different forms of that ANOVA framework that we learned about in the last module. So, in the last module we talked about what are called one-way ANOVAs, and as we've kind of got charted out here, a one-way ANOVA is the most common form of the ANOVA family. And we have some criteria for when we choose that. Remember, the choosing hypothesis test is going to be an important part of this exam and the final exam that's going to come up pretty soon as well. So the ANOVA family of tests here, again, it is always run when there's 3 or more samples of scores that we're comparing to each other, so we can't use our 1 sample or 2 sample hypothesis tests. And again, the context that we learned about, the most common one, is when we have a between participants design and just one factor that there are 3 or more groups being created on. So in that situation, we run what's called a one-way ANOVA, and you can think of the one-way as representing the one factor, but also, again, it is a between participants design. So in this module, we are going to talk a little bit about some of the other branches of our ANOVA family tree here. What happens, for example, if you have a between participants design, but you have multiple factors? You are either manipulating more than one IV, or you're measuring an important quasi-IV in there as well. In that case, we can run what's called a factorial ANOVA. On the other side of things, though, if we have a within participants design, we're going to start by talking about different forms of repeated measures ANOVAs. So they are designed for within participant situations where you are getting 3 or more scores from the same group of people. Some of you may notice, hey, we're missing a branch here. What if there's 2 or more factors in a within participants design? The short version is don't worry about it. We'll talk about a little bit more about that particular branch, but it's not an important one for some important reasons. So we're going to talk about these 2 alternate types of ANOVAs. I will warn you at the beginning of this module that this stuff is a little more complicated conceptually. It can be. But also, we will not actually be running these hypothesis tests. At a certain point, especially with the factorial ANOVAs, it becomes so time-consuming to run the test that there's not a lot of value added there by having you run it. But that means that to the extent you get asked about this stuff, it's going to be conceptual questions. You're not going to be calculating this stuff, but you are going to be expected to know when you run these tests, what the logic behind them is, and how they essentially work. So without further ado, we're going to talk a little bit about the repeated measures ANOVA and some of the considerations that go into that. So again, just to recap, we are comparing 3 or more groups at once with a between participants design and a single factor. We call that, again, a one-way ANOVA. But a lot of times in the real world, you might get 3 or more samples of scores in a within participants design. For example, you might want to track people over time. You want to see if an antidepressant works. Well, the best way to do that is to take people who are unfortunately depressed and track them over time, first before they take the drug, then after a short period of time, then after a longer period of time. 3 sets of scores from the same people. Again, we would need to run an ANOVA, but we can't run a one-way ANOVA. We would need what's called a repeated measures ANOVA. A within participants driving test on the effects of alcohol consumption on driving. Driving errors in a simulator are measured, first while people are sober, then while they are mildly impaired, and then while they are legally over the legal impairment limit. Again, 3 sets of scores all coming from the same participants. Or even some places will track participants for literally decades. There are some really long-term surveys. Harvard has some famous ones that have tracked people for like 50 years straight. And of course, they're measuring that same group of people repeatedly over time. Like here, they might measure their political attitudes over a 30-year period. Those kinds of studies are rare, but they do happen. And again, they're within participants. We're getting lots of measurements from the same folks. So in those contexts, again, we use what's called the repeated measures ANOVA. Repeated measures, you should be able to kind of figure out what that name means, but you're measuring the same people repeatedly over time. So hence the name. So one-way ANOVA, you can think of as being for that one between participants factor. Repeated measures ANOVA, you can think of as we're measuring the same people repeatedly. So here's the biggest difference in terms of how repeated measures ANOVAs are run. They are generally run very similar to a one-way ANOVA. Most of the calculations are the same, but there's one important shift that happens when we switch to a within participants design. Unlike a between participants design, now all of our groups are made up of the same people. We're just measuring the same people multiple times. By the way, here's a thinker. What would happen if an individual stopped giving data before they provided data in every condition. Well, what would we do with that? Now we would have different people in our different conditions. The answer is you'd drop their data from any comparisons where you needed all of those measurements. So if somebody gives me measurements the first two conditions but not the third, I'm dropping those two conditions worth of data they gave me. So in this way, it ensures, again, that all of your groups are made up of the same folks. So here's a crucial difference. Remember when we talked about that F ratio, that key test statistic? I said, all right, the F ratio is the ratio between two different variances, and the different variances have different components, different things that can influence them. One component that was present in both the numerator and the denominator were individual differences. People are already going to differ on your dependent variable. If your DV is happiness, some people are already happier than others before they started the study. You can't control that. You can't eliminate it, but you can try to cancel it out through random assignment to make sure that your groups don't differ on that. But again, random assignment's not perfect. You might just through a fluke of probability wind up with most of your happy people in one condition. With a within participants design, you no longer have that concern. You know that there are no pre-existing differences between the groups you're comparing on the dependent variable or any other relevant variables. Why? Because they're the same people. I know that my 0 BAC driving simulation group has exactly the same basic driving ability as my 0.10 BAC driving group because they're the same people. Those pre-existing individual differences are now eliminated between groups precisely because the groups are made up of identical people. So one big source of variance disappears. Remember this F ratio here, where again we said the treatment effect, individual differences in error contribute to between groups variance, individual differences in error contribute to the denominator. We are going to be working on eliminating those individual differences from both the numerator and the denominator. So it winds up kind of looking like this, just treatment and error divided by error. This is a cleaner measurement. There's less noise in this, so it is more likely to give us an accurate estimate of the treatment effect, which is really, really, really good in a research design. We now call our within groups variance, that denominator, it just generically gets called error variance because that's the only thing that it can be composed of at this stage. So here's the note that we'll leave things off on for now. Some of you, if you've been thinking kind of ahead on this sort of stuff, or if you got a pretty good grasp of this, you might have figured out, hey, a within participants design means that your individual conditions don't have any individual differences, they're the same people, but people within the same conditions, they're still going to differ from each other. Even though you're measuring the same group of people 3 times, you're measuring their happiness 3 times. Some of those people are already happier or less happy than others. So people between groups, there's no difference there because it's all the same people. So on average, the groups are exactly the same. But the individuals within those groups are going to differ. How can we account for that? We are going to talk about how to do that in our next video when we talk about removing individual differences. I will see you there.